Okay, let's see how fast we can get through all of these problems. You weren't expected to finish them all in the 20 minutes you were given, but some of you had valiant attempts. So, how many rectangles of an area of 2 square units are there in the 4x4 square? So, if we start in the top left corner, we could have a rectangle like that. So 2 square units means 2 by 1, right? So we could have that one there. So 1, or 1 to the right, or 1 to the right, or 1 to the right. So that's 4 different possibilities. Or we could shift them down. So there's another 3, so that makes 12 possibilities. But we could also orientate the square the other way around and have the rectangles going 1 by 2 across. So there's 12 possibilities this way, and then there's 12 possibilities the other way around. So the answer is 24. Some of you didn't answer the multi-choice question, which was surprising. Have a guess. You've got nothing to lose. Okay, these are the first 5 triangle numbers. Triangle numbers come from triangles. Funny that. So the second triangle number is a 3, and then the next triangle number is 6. What is the difference between the 10th and the 9th triangular number? So you could just continue that pattern. It's probably the easiest way to solve the problem rather than finding a formula. So 1 to 3 makes 2, then you add 3, then you add 4, then you add 5, then you add 6, then you add 7, then you add 8, then you add 9, and you add 10. And how many triangle numbers have we done there? 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So the difference between the 10th and the 9th is 55 minus 45. Okay, you need to answer the question. If it says difference, don't just give 55 and 45. Give the answer of 10. Okay, I think of a number. When I add 6 to my number, I get A. When I subtract 6 from my number, I get B. When I multiply A by B, I get 45. What is my original number? So we could guess and check this, but foolproof way would be to solve using algebra. So if I take X and I add 6 to it, I get the number A. When I take X and I subtract 6 from my number, I get B. And if I take those two together, A and B, and multiply them, so X plus 6 times X minus 6, I get 45. What's the answer for X? Now, those of you who have been exposed to quadratic equations wouldn't just be guessing and checking at this point, although one of the answers is 9, because X plus 6, if X is 9, 9 plus 6 is 15, and 9 minus 6 is 3, 15 times 3. But if you've been exposed to quadratics, you're going to expand this. Okay, x squared plus 6x minus 6x, they cancel, so you get x squared minus 36 equals 45, which is the same as x squared equals 81. X is equal to plus or minus 9. Both answers work. Although in the Mathex solutions, actually, they only had the number 9 listed there. They said except -9 as well. Both of those work. Okay, question 4. If A equals 1, B equals 2, C equals 3, etc., what maths word does the following represent? So the 8th letter of the alphabet is H, the 5th letter is E, the 24th letter is X, the first letter is A, and so on, and you get hexagon. Some of you had some strange words written down there. It's a maths word, and if it didn't look like a maths word, then you'd probably want to check your word. And probably the easiest way to do that is to say that the 24th letter is X, and it's got to have an X in it. So I don't know many maths words with X in it. Find the pair of consecutive numbers less than 10, which when squared have a difference that is itself a square. Okay, so we could just guess this because there's not that many possibilities. So take a pair of consecutive numbers, let's go, 3 and 4, and when we square those, 4 squared minus 3 squared is 16, and 9, when you subtract those you get 5. That's not a square number. So just go process of elimination there, trial and error, and you'll find that the answer is 4 and 5. That's the pair that we're looking for, because 5 squared is 25, 4 squared is 16, 25 minus 16 is 9, which is a square number. If you're doing it algebraically, then we're going to be going x squared minus y squared. X and y are consecutive though, so we don't need to do it that way, we can go x squared minus x minus 1 all squared. When we expand that out, we get x squared minus 2x plus 1, which is equal to 2x 2x minus 1. And then we're thinking of what x values will make that a square number, and you find that x equals 5 makes it 9. X equals 5 gives 9. So x equals 5 is the highest square number because, the highest of the consecutive numbers, because the other number I chose was one less than it. There are 3 diagonals from a point in a hexagon as shown. If there are 1,000 such diagonals in a polygon, how many sides must it have? Okay, so if we're starting from a particular point and we're sending off diagonals to the other corners, the only 2 corners we don't send diagonals to are the ones that are adjacent to it. So if there's 1,000 diagonals, some of you put 1,002 as your answer, but it's actually 1,003 sides. Okay, because we've got 3 diagonals, which is 3 less than the sides of the hexagon. You've got to consider the fact that you're coming from one particular point here. We don't fire a diagonal off to that side there or that side there, but we're talking about corners here. We also don't fire a diagonal to the corner that you start from. So it's 3 less than 3 more sides than diagonals. So 1,003. The digits 3, 4, 5, 6, 7, and 8 are to be made into a 3-digit number. Subtract a 3-digit number. Question: find the smallest possible difference the answer could be. So smallest possible difference would be the I was going to say the largest difference would be the biggest number minus the smallest number, but we want the numbers to be closer together. Is this just a trial and error kind of approach to it? Well, I guess you want your 100 columns to be as close as possible, because even if your units are as close as possible, if your hundreds are far apart, then you're going to hit a big difference. So if we've got our hundreds column the closest possible, so that would be 5 and 6, and then the tens column as close as possible next would be 7 and 4. That one 4 and that one 7, and then your ones column as far apart as possible 3 and 8, like that. What does that give? 22. It gives 65. No, apparently you can do it in a better way. So I've sent my runner up to the front and I've got it wrong, and it's come back. I feel like we want the lowest ending there and the highest ending there, and then something like that. It's a difference of 4 to 7. That's looking good, and that is the answer. Okay, cool, we'll go with that. Sum of 2016 and another unknown number is divisible by 9 and 11. Find the smallest value. So if we just go 2016 plus x, and we need it to be divisible by 9, you think about all the numbers that are divisible by 9. 9, 18, 27. They all have sums of digits that are 9. It's quite a nice property of divisibility by 9. So if we've got the sum of digits needing to be equal to 9, at the moment we've got that equal to 9, but it's not divisible by 11. So you go to the next number, which would be 2025. That's not divisible by 11. So you go to the next one, which would be 2034, and that's not divisible by 11. And we just keep doing that. Or you write down your 11 times tables, because you get your calculator to do that really, really quickly for you. and we need to be in the ballpark of 2000, so let's go 11 times 180, no, 11 times 190, I'm just using a calculator to do this. Okay, 11 times 190 gives you 2090. So 2090 is an 11 times table, but that's not divisible by 9, so we subtract. So we go 189 times 11, 2079, and that one there has a sum of digits that's divisible by 9. So 2079 is the answer to the question. The smallest value of the unknown number, well, that's 2016. The difference between 2016 and 2079, which is equal to 63. Rachel has 300 little cubes. What is the size of the biggest cube she could build? Okay, so if it's a cube that she's building, it needs to be the same in every direction. So if we take 6 cubes each way, 6 times 6 times 6 equals 216, so that's possible to be made. The volume of a 6 by 6 by 6 cube is 216, but 7 times 7 times 7 exceeds that. So the biggest cube she could make is a 6 cubed cube, 6 in every direction. A farewell dinner has been held for a class of 30 Year 8 students. The desks are placed side to side in a continuous line. Find the algebraic relationship between students and desks. So just make a quick little table of this. 3 desks equals 3, 6, 7, 8 students. If we add another desk on, we just add another 2 students to it, then the person at the end moves along a little. So if I make 4 desks, I get 10 students. The rule is going up in 2s, so it's 2 times the number of desks, but then we've got a plus 2 there because we've got the students at the end. That will be at the end no matter what the arrangement looks like. They're constant people, so that is the algebraic relationship. Okay, so question 11. There are 4 piles of gold coins. The first pile is 4 more than the second, so let's just label these coins A, B, C, and D, or the piles A, B, C, and D. The first pile is 4 more than the second, so A is equal to B plus 4. The second pile is 4 times the fourth, so B is equal to 4D. The third pile is half the first, C is equal to A over 2, and that's 3 equations there, and only so 4 unknowns, but only 3 equations. So we can't find out A, B, C, and D individually. But what we can see there is that A has to be divisible by 2, right? So for example, A could be equal to 2, and if A is 2, then B would be not possible. B would have to be negative, so that doesn't work. So when we go to the next one, A is equal to 4. That would mean B is equal to 0, which means that there's no pile, so that also doesn't work. A is equal to 6 would mean that B is equal to 2, but that's not going to work, because if B is equal to 2, then it can't be 4 times D, so that doesn't work. A is equal to 8 would mean that B is equal to 4, and that's going to work. That's going to give D is equal to 1, and it's going to give C is equal to 4. So that's a possible total, 12, 13, that gives 17. Okay, and then we go A is equal to 10, the next even number. That's going to work for C. It's going to make B is equal to 6, but that doesn't work in that B is going to go up in 4s. So the next possible total for B would be 8, and that's going to make D is equal to 2, and it's going to make A is equal to 12, and it's going to make C is equal to 6. So that's a possible total, 20, 22, 28. And we go to the next one by making A go up by another 4. A goes from, actually no, we'll make B go up by 4, so that's 12. Therefore A goes up by 4 to 16. C will be 8, and D will be 3. So that's 23, 29, 39. And then the last one that's possible, because it says less than 60, is that A is equal to 20, B is equal to 16, D is equal to 4, and C is equal to 10. And if we add that up, we get 16, 20, 40, 50. Those are the 4 possible totals. Okay, find A in terms of B. This question wasn't done well by the classes, which is interesting. It's just fractions, it's nothing scary, but we've got 1 over A times B, because 1 over A times 1 over B is 1 times 1 over A times B. And then these fractions, to put them together, we'd need a common denominator, so we're going to go B over A, because we're going to times, B over AB, timesing the top and bottom by B, minus A over AB, timesing the top and bottom by A, and that's equal to B minus A all over AB. Okay, now there's an AB on the bottom of both, so we can cancel out the ABs by timesing both sides by AB. And then we've got 1 equals B minus A, and the question says find A in terms of B, so we need to make A the subject of it, put the minus A on the other side as positive A, put the 1 on the other side as minus 1, so it's A equals B minus 1. Question 13. In a championship tennis tournament such as the Australian Open, they begin with 128 players. How many matches will they play in total to find the champion? A lot of you said 7. It's 7 rounds, okay? Because if you start off with 128 players in the first round, then that would equal 64 games. Players. And then we half that. That's going to be 64 players left, 32 games. Then we half it again, 32 players left, 16 games. Then we get to the round of 16, which is 8 games. Then we get to the round of 8, which is quarters, 4 games. Then the round of 4, which is semis, 2 games. And then the final. So the number of games is the sum of the right total, which is 96, 106, 112, 120, 127. Okay. Few people put 126 as well, you forgot the final. Zach continues to place regular pentagons as shown until he has made a ring. How many pentagons does he use altogether, and what is the angle of turn of one pentagon to another? So, I think the thing to realise here is that there is the angle of turn, which is an exterior angle of the inner shape. So you need to know that pentagons have an interior angle of 108. A straight line would be another 72. So to get it to 108, we're going to add another 36. Yeah, 72 plus 36 is 108. So the turn is 36. 36 is the exterior angle of the inside shape, which I'm talking about, like this shape here. And so therefore, to work out how many sides that inner shape has got, which is the same as how many pentagons are used, well, the exterior angles are all the same, and they're all going to add up to 360 eventually when we go around in a big loop. So the sum of 360 means that there must be 10 pentagons. 10 pentagons used. Okay. Question 15. A circular cake iced on the top and around the sides is to be shared between X number of people if the radius of the cake is equal to the height of the cake. Find an expression for the area of icing they receive. So let's find the total area first. So if we've got a cylindrical cake and we've got the radius here R, which is equal to that height there. The surface area of the top is pi r squared, it's a circle, and the surface area around the outside of the shape is the circumference of the circle, 2 pi r, times by the height r, because it's just a rectangle. If you pull, like if you have a can and you pull the label off the can, so that's equal to 3 pi r squared. That's the total surface area of icing, and then we're sharing it between X people, so each person gets 3 pi r squared all over x. Okay, question 16. Rachel takes a sheet of paper and folds it in half. She then turns the paper through 90 degrees. She repeats this folding in half and turning 5 more times. The rectangle that she's left has sides A and B. Find an expression for the area of this piece of paper before folding. Okay, so let's start off with like an original piece of paper, which is, I don't know, x by y. Not sure I quite understand this question. She takes a sheet of paper and folds it in half. She then turns the paper through 90 degrees, repeats this folding in half, so it goes that way, and turning. Now let's go back to the start. Let's go to the finish. So if we end up with a rectangle that's A by B, if we halved that, then it would have been 2A and B. Then we turn that around so we're actually going this way. So that's 2B that way. Then we turn it around again. Running out of space here, we get another 2A that way and 2B that way. Then we do it again. So we get 2B that way and 4A that way. And then one more time, but down here, 2, 4, 8A. So it's 8A by 4B is the original paper. 8A by 4B asks for an expression for the area of the paper. So 32AB. Have I done that? So I send that up, the marker comes back and says, wrong, have I done that 5 times? She turns the paper through 90 degrees, she repeats this folding in half and turning 5 more times. Ah, right, so 6 times. So I've only done it, so I did it the once, the twice, 3, 4, I only did it 5 times, I need to do it one more time, so pull that out to here. It's going to be another doubling. So, oh, that was an easy way of thinking about it. If she does it 6 times and it's doubling, so you finish off with AB, so expanding it's going to be times 2 to the power of 6. 2 to the power of 6 is 64, so 64AB. Oh, that makes sense. Didn't even need my diagram for that. But it helped to read the question, make sure we saw it was actually 5 more times. In a game, there are 8 reserves, of whom only 6 may be used. How many different groups of 6 can there be from the 8 reserves? 8 reserves, how many 6 may be used? How many different groups of 6 can there be from the 8 reserves? So 1, 2, 3, 4, 5, 6, 7, 8 people to choose from. And that's 8 factorial, or 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 if you've never seen factorials, which are written like that in maths. And then we're choosing 6 of them. So that is the number of ways. But then we need to think about, a lot of them are going to be the same group, like they're going to be the same people in the group, just in different positions, and we don't want those to double count or anything. So once we've done that, we need to divide by the number of ways that 6 can be arranged. So I'm going to divide that there by 6 factorial, which is a number of different ways of 6 people can be arranged. We don't want to double count them, so we're going to divide by 6 times 5 times 4 times 3 times 2 times 1. I've already got rid of those numbers there because I'm not choosing those 2 people initially. And then I can cancel the 6s, the 5s, the 4s, the 3s. So I've got 56 divided by 2, which equals 28. It's quite a tricky question for year 9 and 10 students. Okay, replace the numbers 1 to 6 in the fraction multiplication below. First to get the biggest answer, then to get the smallest answer. And finally, she found the difference between them. Find Reba's answer. Okay, so the biggest answer would be the largest number divided by the smallest number. So 654 divided by 123. Do that in the calculator. That gives me 5.317. No, I've completely misread this question. There's time symbols in the middle. It's a fraction multiplication. It's not one big fraction. My goodness. So we still want that sort of idea, but I was just doing the numbers wrong. So that top number needs to be as small as possible. So 1 times 2 times 3. And the bottom number as big as possible. 654, but we're timesing. So it's on the top there. 1 times 2 times 3 is 6. And on the bottom, 6 times 5 times 4 is, I'll just write it 6 times 5 times 4, because it can cancel the 6's, that's 1 over 20. So that's the smallest. And then the biggest will be the other way around, so 654 over 123, which is just 20 over 1. Largest is 20. And then if I find the difference between it, it's 20 minus 1/20th, which is 19 and 1/20th. Dan Carter and 30 metres from the try line is 30 metres from the try line, I guess it's meant to say, and at an angle of 45 degrees to the centre of the uprights. So if we've got some posts there, that's what the uprights mean. And it's 30 metres from the try line at an angle of 45 degrees to the centre. So that's 45 degrees to the centre. If it goes through the central point, how far must you kick the ball? So we're looking for this distance here. Trigonometry. Adjacent hypotenuse are known. Cos of 45 degrees is equal to 30 divided by x. So x is equal to 30 divided by cos of 45, which is the same as 30 times the square root of 2 if you work it out in exact form. 30 times the square root of 2 using my calculator, or just 30 divided by cos 45 is 42.43 metres. You don't need units in Mathex, but the question's asking for metres. The area of a cyclic quadrilateral can be found using that formula. It looks very similar to a formula called Heron's formula for triangles, where A, B, C and D are the side lengths of the quadrilateral and S is the semi-perimeter, half the perimeter. So cyclic quadrilateral, so we've got a point here, point here, point here, point here. And we're told sides 1, 4, 9 and 10. And S is half the perimeter. Well, the perimeter of that is 24, so half the perimeter, S must be 12. So we're looking for an area of square root S minus, S is in all of them, so S minus A is 11, S minus B, we've got 8, S minus C is 3, and S minus D is 2. Square root of that, 11 times 8 times 3 times 2, comes out to be 22.98. Give your answer to the nearest whole number, 23 centimetres squared. Cool, that's the Mathex done. There was a few questions that I struggled with, and I guess in those ones, because of the order of Mathex, you either have to do them or pass them, but if you want to get 100 you don't pass. So once you're through those ones, the rest of the questions were pretty reasonable. A few trips up that I had along the way where I didn't quite read the question or misinterpreted the question, but that's going to happen. That's why you work together and you have more brains than one at the table to give different perspectives. All the best in your problem solving, and maybe we'll make another video like this in the future.